Hey guys, welcome back. So we are in our last section of chapter 6, and it's solving exponential and logarithmic equations. It's going to use a little bit of what we've done with the other logs, doing the loop-de-loo, simplifying with the same base, crossing things out, expanding and condensing. We're going to kind of put all that together to be able to solve for x in logarithmic functions and exponential functions. So the two things we need to know with solving exponential and log functions are the properties of equality for each one. So first I'm going to start with just solving exponentials, and then we'll go into logs. So the property of equality for exponential equations is if b is a positive real number other than 1, okay? So as long as that's a positive real number other than 1, if b of x is equal to b of y, meaning the bases are the same, if the two bases are the same, then the exponents equal each other. So if the two bases are the same, you can just get rid of those bases and set the two exponents equal to each other. So sometimes it's going to be easy and you can just set them equal. Sometimes you're going to have to make them have the same base so that you can set them equal. So that's what I'm going to show you in the first set of examples. So I am actually going to erase this. I'm going to rewrite the rule at the top. Just so we can keep it there. All right, so we're going to solve the equations. All right, so for the first one, I have 100 to the x equals 1/10 to the x minus 3. So like I said, sometimes it's going to be easy, sometimes it won't be. These ones don't have common bases, so we have to make them look common. So I think to myself, what base does 100 and 1/10 have in common? Hopefully that's pretty straightforward. 10 has 10 in common. So I know that this has to have a base of 10, and I know this has to have a base of 10. So 10 to the what equals 100? This is when that card I gave you comes in handy once again. 10 squared is equal to 100. And how do I go from 10 to 1/10? Well, remember, anytime you want a reciprocal, it needs to be negative. So that would be -1 x minus 3. So now that my bases are the same, I can get rid of those bases. So the only thing is these parentheses, anytime you see parentheses, you know you got to do. You got to multiply. So these parentheses give me that double exponent. And when you do properties of exponents, when you have a double exponent, a power to a power, you multiply them. So I have 2x, -1 times x equals -x, -1 times -3, it's +3. And from there, I just simply solve. So I add x and I get 3x, divide by 3, x equals 1. Hopefully that one wasn't so bad. Second example. Second example is 2 to the x equals 7. Well, most of you are probably looking at the computer screen like I have 52 heads right now, because that's probably what you would have been doing in class. So what do I do when I have two numbers that have no bases in common? I can't raise 2 to anything to make it look like 7. It doesn't work. So in this case, I have to use the properties from back in section 6.3 when I can simplify things and cross them off when they're the same. So what we call that there is rewriting using a log. So the only way that I can cancel out 2, a base of 2, is log base 2. So I'm going to put log base 2 on both sides. What I do to one side, I have to do to both. And I just want to point out, guys, this is not log times 2. A lot of you are making the mistake on the notes for log times 2. It's not times. It's log base 2. It's a subscript. Okay, so log base 2 of 2 to the x. And again, I have to balance my equation. So what I do to one side, I have to do to the other. Okay. bit because, sorry, we have a little bit of a glare on the screen. So now that I have log base 2 of 2, I know that from section 6.3, I know that those can cancel, and I'm left with x log 2, 7. And again, I know I cannot just plug that into a calculator. Okay, a few of you were emailing me about that. I cannot just plug that in. I have to use the change of base formula. The base, the b is on the bottom. So log 7 over log 2 is approximately 2.807 in the calculator. So let me just show you guys that. In the calculator, log 7 over log 2. Hopefully you guys can see that. Okay, you have to use the change of base formula. I wish I had a clearer webcam for you guys, I really do. I know it's not that great, but we're gonna move on to example 2. Okay, so we have the property of equality for logarithmic equations then. So we just did exponential, we're moving on to logs. So it's kind of the same thing. So before we had b to the x equals b to the y, x equals y. Kind of the same deal. If I have log base b of x equals log base b of y, then x equals y. Again, the bases have to match. The bottom bases have to match, right? And also, just to be so you guys know, these have to be greater than 1. These have to be positive real numbers. Okay, so it's kind of the same thing. A little bit of a glare. See if I can fix this on the screen. A little bit better. All right. So again, I'm going to just scooch that up for you guys. So give me 1 second. All right, so that's what we're going to work off of. Now we have to solve logarithmic equations. So let's start with a simple one. Okay. And again, guys, this is ln, the natural log, not in. A lot of you have been writing. All right. So now keep in mind, guys, this can say ln. This can say log base 5, log base 5, log base 2, log base 2. It doesn't matter. As long as both sides are the same, I can cancel out the ln. Okay? Which leaves me with a good old-fashioned multi-step equation. I'm going to subtract x, add 7, x equals 4. Nice and easy. Okay. Okay, this one's not so easy because I have log on one side, great, don't have anything on the other, so I can't just simply cancel them out. So this is when I'm going to do exponentiating. So exponentiating is raising these up to become exponents and putting in a base that will allow me to cancel log base 2. So again, from 6.3, you guys should remember the only thing that can cancel out log 2 is a base of 2. It has to be the same thing. But what you do to one side, you have to do to both. So I'm going to raise this side up. And I'm going to raise that side up. So again, these just came up and became exponents. All right. So now I know that that cancels. And 2 to the third, if you don't remember off the top of your head, you have your card I gave you, is 8. Now we just solve it. So add 17. X equals 5. Hopefully that's not too bad. Okay, our last example is a little bit harder because it involves multiple steps. This is solving logarithmic functions when you have to actually condense the equation first. That means there's multiple pieces on the one side. You can't just raise it from log. You got to condense it, then exponentiate it, then solve it. So we're going to go over one of those now. So whenever you see a binomial, trinomial, multiple logs, you have to bring it into one. So this one we have addition. And you guys should know from the product property that when you multiply, you add, you multiply, depending on which way you're going. Here I have addition. I want to condense, so I'm now going to squish these together and multiply them. So they both have a log, so I'm good with that. Now it should be 2x times x minus 5. I want to make that look a little prettier. So I FOIL. 2x times x is 2x squared. 2x times negative 5 is negative 10x. I'm sorry, I know there's a glare here. Really nothing I can do about it. Equals 2. So the only way to get rid of a log, once again, is to exponentiate. When you exponentiate, you have to use the same base. So remember what I've said in the past chapters. If they don't give you a base, you assume that it's 10. I also want to add, in case you get an ln, you can exponentiate it from e, because e would cancel ln cancels e, vice versa. So if you get those problems, you can use e or ln. This one, we're going to raise it from 10. So I'm just going to add the 10 here so I don't have to rewrite it. All right, that'll cancel that. So I have 2x squared minus 10x equals 10 squared is 100. Okay. We know when we have a quadratic, or we should by now, in order to solve a quadratic, everything has to be set equal to 0. Okay. 2x squared minus 10x minus 100. We got a factor. First rule of factoring, GCF. Oops. 10 divided by 2 is 5. Okay, we took out 2, which leaves us with x squared minus 5x minus 50 equals 100. I'm going to bring it up to the top to finish this off here. Actually, I'll get rid of all this. I'm going to bring this up here just so we can see it. So I'm left with this. I think I said equals 100 before. Equals 0. Losing my mind. All right, so I think you guys might miss this, but when there's 3, we make the t. Come on, you know you missed it just like a little bit. All right, so a times c, what adds to b? We're looking for what multiplies to 50 and adds to negative 5, negative 10 and 5. So our answers, you would think, are 10 and negative 5. But you cannot, and I repeat, you cannot have negative logs. If I plug in negative 5 to negative 5 minus 5, that's negative 10. I cannot have negative logs. So that one's out, and our answer is 10. All right, well, that is all for chapter 6. I have assigned you guys homework. I'm going to do an optional review before, because this is a test grade. It will be your first test grade of marking period 4. Again, I miss you guys so much. I was hoping to get to see you, but we're just going to have to deal with me on a computer screen for a little bit. All right. Have a good one, guys.